Hello everyone, today we have a brief video on albedo. This is a property of surface. So albedo is a measure of how much light or radiation a surface reflects. And we've talked a little bit about radiation in the past. You can see some examples here of things that reflect light. So this light is traveling from the sun, it's traveling through space all the way to our planet, and then it bounces off of the various objects. And some of it bounces off, some of it gets absorbed. The amount of energy that bounces is dependent on the property of albedo. High albedo, like fresh snow, and 80 to 95% of that energy is reflected. Something like black asphalt, though, will only reflect 5 to 10% of that energy. That means the rest of it, the 90% of that energy, is absorbed by the asphalt. This will keep a city warm compared to the same energy for a field. So a grassy field, it reflects about 25 to 30% of the energy. We can see that right here. So when this energy comes down, we can think about it as the energy comes this way, and we get, we have 100% coming down, and then there's 25% here that goes this way, and the other 75% goes into the ground. With the case of asphalt, we have 90% goes into the ground, and only 10% is reflected. So this is a big deal because this means that things like oceans, where oceans like this, where that can absorb up to 60% of the energy, those are going to be really important to heating and cooling the Earth. On average, the Earth is at about 31%. This is one of the reasons that when it's cold and the ground stays cold. Because if the ground is covered in fresh snow, then 95% of the energy is being reflected away. If we clear the snow, so if it, in the winter for me, I go to my walk and I clear my walk early after a snowing, and then my asphalt or the cement that makes up my walk is going to be uncovered, and it'll be this dry concrete. And that dry concrete will absorb some of the energy. It will have a less reflectance, less albedo than the snow. So it'll absorb energy during the day, and I'll actually find that places that I didn't shovel the snow will actually start to melt away because the concrete has warmed up from the absorbed energy. Okay, so non-shiny surfaces, they have lower albedo. So of course a mirror has almost perfect albedo. It should be reflecting close to 90, 100% of the light. But but if you ever have seen a mirror where someone has scratched it, or they've taken some sandpaper to a mirror, you'll notice that the reflectance is much lower. If an object's surface absorbs more light instead of reflecting it, then the object will tend to heat up more quickly. Therefore, albedo of different parts of the Earth can cause uneven heating as well. So this fits well with our previous lesson about uneven heating. Now, color does have an effect, particularly dark objects. Dark objects are dark because they're absorbing energy. So if they're true black objects, then they will be absorbing all of the visible light. And that means that there's very little light that's escaping. And also, if they're perfectly white objects or anything close to white, then they'll reflect all the visible light. Now, you could also think that there's some effects from colored objects. So remember that our color spectrum goes from red, right? We think of our rainbow, it goes from red, I should do orange, red, orange, yellow, green, and then we have blue, and then we have violet, and that's our rainbow. And in this energy, in this color spectrum, this is higher energy. But when you actually see something, the way you see it is that the light has been reflected by that object. So a colored object that's purple is reflecting violet light or reflecting purple light. An object that is red in color is reflecting red light, and that means it's probably absorbing the other colors. So there could be some argument that something that is green or blue or purple is actually reflecting those higher energy wavelengths, and so it might feel a little bit cooler. So maybe if it's cooler, I don't know, a little bit of conjecture there. One of the things that's interesting about green is that if you take the colors of light that come from the sun, green is one of the is uh, is related to the amount of color coming to the sun. That's why so many objects are green. Figure 5 here shows how much energy different parts of the Earth are reflecting. And so this is an albedo ranging from 0 to 0.4. So I guess that's up to 40% reflectance. And you can see that in the middle of that, well, we don't have the oceans colored in, but we can see there are lots of there is much higher albedo up in the northern climates where we have lots of snow, and there's less albedo in these areas here where we have less snow and we have more absorbent materials, absorbent colors. So the data was collected by a new sensor aboard NASA's Terra satellite. I'm sure this is probably updated even now to a better satellite, which is collecting the most detailed and accurate measurements ever made about how much sunlight the Earth's surface reflects back up into the atmosphere. By quantifying and precisely our planet's reflectivity, or albedo, we can better understand and predict how various surface features influence the broad short-term both the short-term weather patterns and long-term climate trends. And so there's an interesting thing happening, for example, in watching how much ice there is on the ice shelves. If the ice shelves are shrinking under climate change, then that means there is less white ice at the top and bottom of the planet. And without those polar ice caps, we have less reflectance. Less reflectance means more absorbance. More absorbance means more heat is going into the planet, less heat is going out of the planet. And if the oceans are rising, that means the oceans are getting bigger. And according to our first image, the ocean is one of the greatest energy absorbers on our planet. So the larger the ocean gets, the more energy is absorbed into the ocean. The more energy that's absorbed into the ocean, the hotter the planet gets, which will then melt the ice, and so forth and so forth. And so it will become a cycle. There's an experiment you can do with that's very simple, where we take a pop can, we paint it white, and we paint another pop can black, and then we use just a regular incandescent bulb, like a regular light bulb, and heat up both cans with thermometers inside. And you'd be able to find out that the black can is going to heat up a lot more. And it's something we experience a lot. But I do want to look at the questions at the end of this section. So right here on the conclusions. So albedo measures the percentage of light that is reflected from a surface. Which color, white or black, would have a higher albedo? And in this case, we'd be talking about white. White is a perfectly white object is perfectly reflective. It's reflecting all colors of light. And the black object would have a lower albedo. It has more absorption. Let's put a little note here about more absorption. Meanwhile, why did the temperature of the air increase so much faster than the water temperature, even though the same energy was used in both? Well, air has a lower heat capacity. So the heat capacity of water is higher, so it takes more energy to heat it the same amount, heat it to the same temperature. And this is going to mean that that it's going to seem like it takes longer for the water to heat up. But it's just that the water is better at absorbing that heat than the air molecules. You build a snow person with coal eyes. So we're talking about, one of these classic snowmen where we put these little coal eyes on them right here. And maybe we'll put some sticks on them. And every year I've tried to build one of these with my sons. And yeah, there's a problem that happens when you're making these snowmen, is that you make them, they look really nice the first day, and then you get a nice sunny day, and suddenly the eyes fall out, or the dots on their arms, or even the branches will fall out. And it's because that when the light rays are coming towards your snowman, they are going to be reflected away from the white parts, but when they are coming towards the eyes, they will be absorbed. Those eyes will heat up more and more, and then they'll actually start to melt the snow around them. So how might albedo affect the weather in a region? So for example, the Arctic, if you have the high albedo of the snow in the Arctic, prevents the ground from heating up. Meanwhile, something like a desert where there is lots of sand. So maybe let's even write this down here. So in a desert, so in a desert, the sand, the rough sand has a lower albedo, so it heats up. And so, part of the whole thing with the sand is that it gets hot and it's hard to, you have to think about how animals have to have adaptations for running on those hot sands and stuff like that. I'd like to talk about clouds in this last question. So let's think about clouds. Clouds are white, so they reflect a lot. That means that their albedo is fairly high. So when those clouds are up in the sky, you'll actually notice that the day will usually, on average, seem to be a little bit cooler, because those white clouds are actually protecting you from the sun's rays. They're going to be they'll actually be reflecting that energy from the sun back into space, or back into the upper atmosphere. Okay, well, hopefully you found this interesting and helpful, and we will talk to you in the next video.